In a previous video, I did some exploratory data analysis in Python on the emergency dispatch response times for fire department calls received by the city of San Francisco. I went through data frame conversion in Python, and I got to some EDA where I showed the mean dispatch time per battalion, per final disposition, per call type, for this very, very large data frame. I mentioned that it would be easier to do this in SQL. The first time I was working on this project, I was having trouble loading the CSV, but luckily I was able to fix that and recreate this project in SQL, and it was much faster. Python, I believe, is an interpreted language, not compiled, so it does not run as quickly as other coding languages. Here I show the basic Python script on how I was able to upload this huge CSV into my Postgres SQL database that I run locally on my PC. Just put my user, password, host, port, database here. Didn't put the actual ones, obviously, since I'm recording this. And this still took a while. I'm guessing it took like 30 minutes. Like I mentioned previously, it's a 6 million plus record database with 37 columns. I do enjoy the SQL Alchemy and SQLite package and their interactivity with pandas, or Python I should say, and SQL. I use that combination a lot at work as I'm getting better with SQL. So here I've uploaded the actual SQL queries that I wrote to GitHub, but that would be a boring video, so I'll show you how it works in VS Code. I've connected to my server, so I should be all ready to run. Here I'll run a duplicate where I'm checking for the unique column IDs of column number, unit ID, incident number, etc. Before that, I should show you what this data set contains. Here you can see there's 37 fields, multiple timestamps. I'm concerned about the difference between these two, the dispatch time and the time a call is received. And I'm using these three fields here, call number, unit ID, and incident number, as my unique IDs. So I'll run this here. It has a count of 0. Then I'm doing my permutations. Got unit ID and incident number. See if there's any duplicates between these data sets. Nothing's found. Going to run this one. Now I have the count of the groups between unit ID and call number. And you're going to see right now why I have limit 5. Alright, guess not yet. So this combination also has no duplicates. But if you look for duplicates based on the unique ID characters of call number and incident number, well, now you can see there's 2 for the first grouping, whatever it may be, 2 for the second grouping, whatever it may be, 3 for the third. I know that duplicates exist on my unique identifiers, call number and incident number. I'm going to inspect this further by creating a table that only contains duplicate values. So I start with a CTE, duplicate IDs, select call number and incident number, the unique fields, or the fields that contained duplicates that I've defined here as unique IDs, and the count for all of those. From my data set that I uploaded as a table called fire department calls, I'm grouping by the 2 unique IDs just like I did again, but here, same logic. I'm selecting the call number, incident number, and their counts for when they have a count greater than 1. That will make sure that only duplicate records get included in this data set. From that, I'm selecting all the columns from my original table, fire department calls, that join to the duplicate IDs. Call number will be the same on f.callNumber, d.callNumber. Incident number will be the same. And I'm going to order them by call number and incident number. Limit 5, I just want to take a look at this. I don't want all 3 million of the records that I saw from when I did this in Python. So you can see here that took about 45 seconds to run. I'm guessing partly because this is a huge data set. Also, I'm sure my queries could be optimized. Feel free to mention it in the comments. I'd love to learn. I'm trying to break into the data industry, so this is how you do it. Here I see a call number of the same call number. That's why I ordered them. Makes sense. I see unit ID, different. Incident number is the same as they should be. Medical incident. But here, these are the same, these are the same, these are the same. And if I go through this entire table, I'm going to see that my unit types are what's different. So here it's unit ID. Now you can see all the columns I didn't have in the Python dataset since I was using a Jupyter notebook. But yeah, unit sequence is going to be different. Unit type is going to be different. Here it's a medic, here it's an engine. The data dictionary that came with this data set actually tells you that the unit ID corresponds to the unit type. So M, medic, E18, engine, fire engine. That's going to make sense. So on one call you have multiple unit IDs and multiple unit types. I'm going to remove duplicates, and I'm also only going to focus on the timestamps I care about. That's my dispatch timestamp and my call received timestamp here, received. How I do that is with another CTE. So with ranks, looks like I'm using the rank or row number Windows function. I'm selecting my row number. I'm partitioning by those two unique IDs that I've decided to find duplicates on as row num. I'm selecting only the columns of interest, and I chose these from my Python project. Didn't want to reinvent the wheel here since I already knew what I was looking for. So after creating row numbers for all these field types, you're going to have row numbers 1 and 2 if there are duplicates. If there aren't any, it'll just always be row number 1, which is seen here in the query underneath the CTE, where I select all the relevant fields from my rank CTE where row number equals 1. That's going to get rid of my duplicates for me. Here I'm looking at my non-duplicate exploratory data analysis statistics. So I'll go back to my Python project here. When you do dataframe.describe in Python, it gives you a bunch of stuff: count, mean, standard deviation, min, the different quartiles, the maximum, and then I aggregate it over mean, median, sum, standard deviation, max, min. So I tried to replicate this outcome that you would get in SQL. That part is not always as easy. Python's describe or ability to pull statistics quickly does trump SQL in that manner. But doesn't matter when you're working with a database. So with my ranks as, I'm selecting just to partition my call number and incident number as the row number. I'm only pulling these two fields now: receive date time and dispatch date time. Recall, I'm going to want the difference between these two to get the actual time it takes from when a call comes in to when they dispatch emergency vehicles. Second CTE, I have non-duplicates. So I'm selecting just my 2 timestamps from the previous CTE, where row number equals 1. That kicks out my duplicates. So I have my final CTE here, seconds. There's a lot going on here. So I'm going to start from the inside out. In the Python project, I noted that my timestamps got loaded as strings or varchars. So here we're casting these as timestamps. Here for the dispatch date time, here for the receive date time. I'm subtracting these now that they're timestamps. Epoch from is going to give me the results in seconds. That's specific to PostgreSQL. And then extract epoch, I believe that's what gets you the seconds here. I had to look up this documentation. I'm still getting used to not date data in SQL, but timestamps itself. Pulling seconds is always tricky. I pulled this from the non-duplicates, so I'm making sure I only have the non-duplicated seconds that were partitioned according to that rank I mentioned previously. Finally, I can get to my summary statistics. I'm looking at a count of the dispatch seconds, the average dispatch seconds, standard deviation, sample, because this is not all the dispatches in the entire San Francisco fire department of all time. This is, even though it's 6 million records, or more like 3 million now, it's still going to be a sample. Since population statistically is more or less defined as an entire group where you don't miss a single person. Here I have the maximum dispatch time, the minimum dispatch time. I took out the percentiles here, so 0.25, Q1, 0.5, that's median, 0.75, Q3, and I've got the sum here, rounded to 2 decimal points. And I have all these where dispatch seconds is greater than 0. In the Python dataset, I saw that my minimum value had about 237 records with negative seconds. That doesn't make sense. So I made sure to include that when writing this query. This is a big one, and I'll definitely be skipping forward. It's probably going to take a minute or 2 to run. Glad I paused the video. This took 1 minute, 47 seconds to run. Don't want to look at all that blank space. But I get my summary statistics here of the overall dispatch times it's taking from the fire department to receive a call to the time they send out dispatch help. Here I mentioned that you're going to have to repeat the CTE series above with corresponding fields basically grouped. For my Python project, I was looking at groups by call type, call final disposition, and battalion. Since these queries take a hot minute, I showed an example using battalion. That said, replace battalion with any other field you wish to group by, and you'll get the same results. So here I've got the rank CTE again. I'm using row number to partition. I keep in my timestamps that I want, and battalion from the original table fire department calls. I've got my non-duplicate CTE here as selecting both the timestamps and now battalion as well, where row number equals 1, hence non-duplicates. Seconds, again, now I'm pulling seconds from the previous CTE, non-duplicates, but I also make sure to include the battalion for each amount of time that passes per dispatch. You can imagine if I just stopped here, the result of this would just be a huge table with a list of battalions and a time. So here I'm selecting battalion, what I wish to group by, the same summary statistics as before. And the difference here is after my where, I'm adding another group by statement. Group by battalion here. And this was a long one. And when I first wrote this, I actually wasn't too efficient. I included all the columns in my query instead of just the 3 I need. So you can see that on GitHub. I think I left it as first draft. Ultimately, I was able to get that down from 220 something to the 191 lines of code I have here. Again, I'm glad you can pause videos or skip, because this took almost 2 minutes to run, 1 minute 50 seconds. But you can see here I've got my battalions, I've got the count of their dispatch times, their average dispatch time, standard deviations, max, min, Q1, median, third quartile, the sum, and let's see if this will work. Alright, I'll do a side by side. So if you look at the battalions here, at least the head, you can see my mean here, 55.5. Where'd that go? Average, 55.5. Median, 57.5. Median here, 57.5. So I was successfully able to replicate this exploratory data analysis in SQL. It did not take as long as it took to load in Python, even though it did take about 2 minutes for these very large queries, which I'm sure could be optimized. Please let me know in the comments or wherever you want to tell me. It took a lot less time than it would for Python to run it, which was about 5 to 10 minutes just for that group by and aggregate statement to run. I knew kind of when I was making this project in Python that SQL would be the better language, but I was having trouble loading the CSV, but fortunately I was able to come back to it. With that said, thanks for listening to my project, and I hope by the time I edit this it's nice and short.